Hi everyone, I am Ragini from Section D from TSWRDC Jagadgirigutta. I am pursuing BSc Data Science second year. Today I am going to discuss about the Rolle's theorem, which is very important and very useful. Let us know the Rolle's theorem. For this Rolle's theorem, we have the statements and condition. The statement is let f be a function that satisfies the following hypothesis, and the conditions for the Rolle's theorem. Let us see the conditions. And the first condition is f is continuous on the closed interval a comma b. Let's go to the second condition. What is that? F is differentiable on the open interval a comma b. This is fine. And let's move to the third. And third condition is that f of a equals to f of b. Then there is a number c belongs to a comma b such that f dash of c equals to 0. Here we have the proof. In this proof we have three statements. First one is when f of x means that constant, that may be any constant. Let us suppose that constant is a k. If we draw a diagram at a point a and at point b, the function is continuous is given at f of a and f of b. Yes, so the number c can be taken at any number in a comma b. It implies f dash of c equals to 0. Hence we prove that f dash of c equals to 0. And the first case is proved. And let's move to the second case. That is f, f of x greater than f of a. Here we draw a diagram. Let's suppose that f of x is greater than f of a. What does it mean? The curve has point at a and at b. Let us suppose this f of x. We can observe this in a curve. F is greater than. For example, this point, what will happen here? Here the maximum value is there somewhere in between a comma b. Let f of x greater than f of a for some x in a comma b, then in a open interval, then f has a maximum value somewhere between a comma b. Since f of a equals to f of b, it must attain the maximum value that a number c in the open interval. Then f has a local maximum at c. Then f is differentiable at c. Finally, we prove that f dash of c equals to 0. Here the case 2 has proved by f dash of c equals to 0. Here f of case 3. What is the difference between case 2 and case 3 means? Here in case 2 we discuss that f of x greater than. Here we discuss less than. And we take here minimum value. There it is maximum value. F of x less than f of a for some x in a comma b. By the extreme value, f has a minimum value in a comma b in a closed interval. And we know that already we discussed that f of a equals to f of b. It attains this mean minimum value at a number c belongs to a comma b. Again we have to do the differentiable for the f dash of c. We can get here we get that f dash of c equals to 0. Why? Because the constant number is equals to the 0 by doing the derivation. So by these three cases we can prove the Rolle's theorem, which is very easy and which is very important. Thanks for giving this wonderful opportunity.